Imagine you're trying to build like the ultimate world-class kitchen. You want the absolute best Italian espresso machine, the finest Japanese steel knives, and, a top-of-the-line German oven.
Oh, absolutely. It's a
Yeah.
dream setup.
Right. But then the contractor looks at your blueprints and tells you, sorry, if you buy this specific oven, you are legally forbidden from putting that espresso machine in the same room.
Wow.
Yeah, you have to pick one brand for everything. It's basically an artificial walled garden,
Mhm.
and for a long time, that forced compromise is exactly what enterprise cloud AI felt like.
It really was.
You had to choose your provider, lock in your data, and just sort of hope they kept up with the relentless pace of innovation.
Well, the week of April 26 to May 2, 2026 fundamentally shattered that walled garden.
It really did.
We're looking at this incredibly dense stack of updates surrounding AWS and Amazon Bedrock that frankly signals a structural shift in the entire market. I mean, the historical exclusivity that Microsoft Azure held over OpenAI,
Yeah.
that's completely gone.
Gone.
Yeah. And simultaneously, we're seeing Amazon Bedrock transition from what used to be a simple model marketplace into a full stack, highly secure operating system for autonomous AI agents.
So, if you're building an AI architecture right now, the ground just shifted beneath your feet. Our mission today in this deep dive is to, cut through the press release fluff and examine the actual mechanics of these updates. We're
Exactly.
dissecting the new frontier models, the developer tools, and even the physical custom silicon infrastructure to figure out exactly how these changes impact your deployments.
And to understand the magnitude of what just happened, we kind of have to start at the foundational layer, right? The cognitive engines themselves. Because you cannot build a complex autonomous agent without a world-class reasoning model powering it.
Right. And this week brought a massive and honestly unexpected influx of those frontier models directly into Bedrock.
It was huge.
On April 28th, AWS launched limited preview support globally for OpenAI's latest frontier models. We are talking about GPT 5.5 and GPT 5.4, accessible natively within Amazon Bedrock. But wait, let me stop there. Didn't Microsoft Azure have a, titanium-clad exclusive lock on OpenAI for Enterprise Cloud?
They did, yeah.
So how is AWS legally and technically pulling this off without compromising security?
Well, the exclusivity contract structure obviously evolved, but the technical execution here is what really matters for an enterprise.
Mhm.
AWS isn't just brokering some proxy connection over the public internet to an external OpenAI server.
Okay.
These models are integrated using existing AWS APIs, and more importantly, they are wrapped in AWS Private Link.
Let's define private link for a second because, that's the linchpin, isn't it?
It absolutely is. So Private Link is a networking capability that allows your virtual private cloud, your VPC, to connect to AWS services without the data ever traversing the public internet.
Right.
Previously, if an enterprise wanted the reasoning capabilities of OpenAI's newest models, but their proprietary data and compliance frameworks were, entrenched in AWS, they faced a nightmare.
Yeah, because leaving AWS to hit an external OpenAI API basically meant punching a hole right in their security perimeter.
Exactly. Highly regulated industries simply couldn't do it.
So they compromised. They used lesser models or they just delayed their projects entirely. But if Private Link keeps the data off the public internet, does that mean a company can now securely hot swap between models?
That is the ultimate implication here. Bedrock is now the definitive multi-model hub. An enterprise can access OpenAI, Anthropic, Meta, Mistral, all through the exact same API.
Wow.
You can dynamically route a complex reasoning task to a GPT model and then send a massive document processing task to a Claude model without changing your underlying identity and access management rules or, your orchestration code.
I see the appeal there, but let me push back on that a bit. Is hot swapping really that seamless? A prompt that works brilliantly for Claude might cause GPT 5.5 to completely hallucinate. Aren't companies still essentially locked in by their prompt engineering?
That's a very real challenge, yeah. The prompt structures do vary. However, the infrastructure lock-in was the true bottleneck. Rewriting a system prompt, that takes a developer a few days.
Right.
Re-architecting a secure, compliant cloud environment to support a new vendor, that takes 6 months and millions of dollars. AWS just eliminated the multi-million-dollar friction.
That makes total sense when you put it that way. And, it wasn't just the commercial frontier models making waves either. On April 29th, AWS announced that OpenAI's open-weight GPT OSS models, specifically the 120 billion and 20 billion parameter versions, along with NVIDIA's Nemotron models, were added to AWS GovCloud in the US.
Which is massive. GovCloud is a highly isolated environment designed specifically for public sector agencies handling sensitive or classified data.
Right. Very strict rules there.
Exactly. So bringing open-weight models there is a huge leap. But the underlying mechanics of how they're serving these models is the real story. They're using a new distributed inference engine called Mantle.
Let's unpack Mantle, because when we say a 120 billion parameter model, we are talking about an AI brain with 120 billion simulated synapses. Trying to run that requires immense physical hardware. How does Mantle actually manage that complexity?
Well, when you have a model that large, it literally cannot physically fit onto a single graphics processing unit, or GPU.
Okay.
You have to use a technique called tensor parallelism that slices the model's neural network into pieces and then distributes it across multiple GPUs. Those GPUs then have to talk to each other in milliseconds just to generate a single word. Historically, setting up that distributed infrastructure was incredibly brittle.
It sounds like trying to get 8 different engines to turn one drive shaft perfectly in sync.
That is a perfect way to visualize it. And Mantle acts as the automatic transmission. It abstracts all of that distributed serving complexity away from the user.
Oh, nice.
Yeah, it provides highly performant serverless inference that automatically scales. So if a public sector application experiences a sudden 10x spike in traffic, Mantle dynamically provisions the multi-GPU clusters and orchestrates all that tensor parallelism behind the scenes. It ensures the infrastructure scales without hitting a bottleneck.
So having a massive, perfectly orchestrated brain is phenomenal. But an isolated brain is essentially useless if it doesn't have hands to do the actual work.
Right, exactly.
To act on data, developers need tools to build autonomous software around these models. And that brings us to the developer platform updates, which fundamentally rethink how applications are built.
We're shifting from an era of conversational chatbots to an era of agentic software. Programs that can independently plan, execute, and iterate on multi-step tasks.
And on April 28th, AWS released a global preview introducing Codex, OpenAI's coding agent, directly into Bedrock. Developers can access this via the command line interface, desktop environments, and right inside Visual Studio Code. And simultaneously, they launched Amazon Bedrock Managed Agents powered by OpenAI, which bundles these models directly with Bedrock's AgentCore compute environment.
The integration with AWS CloudTrail is the critical detail here, though.
How so?
When a developer uses Codex natively on Bedrock, they authenticate with their standard corporate AWS credentials. That means every single line of code generated and every action the agent takes is immutably logged.
Ah, for auditing.
Right. Development teams can build production-ready agents within the strict governance boundaries of their corporation, rather than just using, shadow IT tools on the side.
And to make building those agents even more accessible, the AgentCore Runtime just added native support for Node.js.
Yes.
Now a developer can write their agent in JavaScript or TypeScript, bundle it into a simple zip file, and just deploy it. No Docker containers to manage, no Kubernetes clusters to untangle.
Removing the container management is huge, but honestly, the language shift is even more structural. Historically, the AI ecosystem has been almost entirely dominated by Python.
Right. Python is fantastic for data science and heavy math. But if you look at the structure of the internet, it's basically built on JavaScript.
Exactly.
So giving web developers the ability to use JavaScript isn't just about familiarity, it's about architecture. JavaScript is inherently designed to handle asynchronous events, like waiting for an API response, updating a user interface, and fetching a database record all at the exact same time.
Which is exactly what an AI agent does when it orchestrates a task.
Yeah.
It's an asynchronous workflow.
Right.
The architectural alignment is spot on. Python is synchronous by default, which can create bottlenecks in multi-agent orchestration. By natively supporting Node.js, AgentCore allows the largest developer community in the world to leverage a language purpose-built for event-driven orchestration.
So you just upload your zip file.
You upload the zip file, and AgentCore handles the session, isolation, the authentication, and the bidirectional streaming required to actually make it work.
But, deploying an agent built in Node.js is really only half the battle. Once that agent is live in the wild, interacting with unpredictable human users, how do you mathematically prove it's actually doing a good job?
That has been a massive blind spot.
Right. On April 30th, AWS launched a preview of AgentCore optimization capabilities globally to address this exact problem.
Up until now, optimizing an AI agent was a highly unscientific process.
Yeah.
A developer would, change a few words in a system prompt, manually test 5 or 6 queries, cross their fingers, and push it to production.
It was essentially software engineering based on vibes.
Absolutely, which is terrifying at an enterprise scale.
Seriously.
But with these new optimization tools, the system introduces rigorous MLOps disciplines. AgentCore can now analyze production traces, which are detailed logs of how the agent behaved in real user sessions, and then generate automated recommendations for optimizing the system prompts.
Wait, let me stop you there. Are we essentially letting the AI agent manage and rewrite its own underlying instructions? I mean, how do you even measure better when the output is a dynamic conversational response?
You measure it through statistical batch evaluations and semantic similarity metrics like RG scores or embedding distances. The agent doesn't just hallucinate a new prompt and blindly apply it.
Okay, good.
Yeah, the system generates a proposed optimization, and then it runs a batch evaluation against thousands of historical test cases to see if the new prompt yields more accurate tool selections or, say, better formatting. Then it utilizes statistical A/B testing.
Oh, wow.
Right? You route 10% of your live traffic to the new prompt and statistically prove it performs better before promoting it to 100% of your users.
So it basically prevents that slow, invisible performance degradation that happens as user behavior naturally evolves over time.
Precisely. It turns prompt engineering from an art into a measurable automated science.
Okay, if you're managing an enterprise IT budget, this next segment completely upends your hardware forecasting. We're talking about software doing asynchronous, parallel A/B testing, orchestrating API calls, evaluating thousands of historical logs. That requires serious physical metal. Way is this actually running?
Well, the physical reality of the cloud often gets kind of obscured by these flashy software updates. But the silicon strategy we saw unfold this week reveals exactly where the industry is heading.
On April 27th, Meta and Anthropic significantly deepened their custom silicon partnerships with AWS. Anthropic is co-engineering with Annapurna Labs, which is Amazon's custom chip division, to train its most advanced models on AWS Trainium and Graviton processors.
Right.
And even more surprisingly, Meta signed an agreement to deploy tens of millions of AWS Graviton cores specifically to power agentic AI workloads.
The emphasis on Graviton is the critical takeaway here. Graviton is a central processing unit, a CPU.
Right, and I think the average person assumes AI is strictly a GPU game. You buy the biggest graphics cards available to run the math. Why on earth is Meta buying tens of millions of CPU cores for AI?
To answer that, we have to look at the division of labor within an AI system. GPUs are incredible for matrix multiplication. The massive parallel number crunching required to predict the next word or the next pixel. But an autonomous agent does more than generate text.
Right.
It involves complex multi-step orchestration.
It basically has to decide what to do next based on the text it just generated.
Exactly. The agent has to perform branching, if-then logic. It has to search through a vector database, execute a snippet of code, evaluate the result, and determine its next API call. Those tasks are sequential. GPUs are terrible at sequential branching logic. That is the domain of highly efficient CPUs. So Graviton provides the targeted performance needed to run that massive orchestration layer sitting on top of the generative foundation models.
So the GPU is the creative engine, but the CPU is like the strict project manager, making sure the work actually gets done sequentially.
That's a great way to put it.
And AWS is pushing this infrastructure globally to get those project managers closer to the end users. On May 1st, the full suite of AgentCore capabilities launched in the South America, São Paulo region.
Right. And deploying in South America is partially about drastically cutting latency, but more importantly, it addresses strict domestic data residency laws.
Let's talk about those residency laws, because if you are, say, a financial institution in Brazil, your country's regulations likely dictate that citizen financial data cannot cross international borders.
Correct. Previously, if you wanted to utilize a frontier AI agent, you had to send your data to a server in Virginia, process it, and send it back. That crossed borders, violating compliance, and effectively locking those institutions out of the AI revolution entirely.
Wow.
But by standing up AgentCore locally in São Paulo, an enterprise can build complex multi-turn AI agents that process every token entirely within their own sovereign borders.
So you have custom Graviton CPUs processing localized data in Brazil, running an asynchronous Node.js agent that just decided it needs to query your proprietary HR database to answer a user's question.
Yes.
From a cybersecurity perspective, handing an autonomous software agent the keys to your corporate database is a nightmare.
Security in the agentic era is literally the single largest hurdle preventing enterprise adoption.
Mm.
If the agent acts on behalf of the user, how do you verify its permissions at scale?
Right.
Well, the updates to AgentCore Identity on April 30th addressed this massive pain point. They introduced the On Behalf of, or OBO, token exchange into general availability across 14 regions.
This solves the multiple consent friction. Let's break down the mechanics of an OBO token. I like to think of it like a valet key for a car. If you hand a valet your standard keychain, they could theoretically drive to your house, unlock your front door, and open your safe. That is a standard access token. It just holds way too many permissions. An OBO token is a specialized key that only turns on the engine and unlocks the driver's door. The valet gets exactly what they need to do their specific job and absolutely nothing more.
That analogy translates perfectly to software architecture. Imagine a user asks an AI agent to book a corporate flight and then update the internal HR expense system. Historically, the agent would have to pause and prompt the user for manual approval at every single step.
Just constant pop-ups.
Right, asking for one token for the travel API and then a completely separate token for the HR database. It creates an unusable experience.
But with the OBO token exchange, the agent takes the user's primary access token and swaps it behind the scenes for a new, highly restricted token. This new token proves the identity of the user and the identity of the agent, granting just-in-time, least privilege access to the HR database. The agent does its job seamlessly, and every action leaves a perfect cryptographic audit trail.
Exactly.
But wait, let me challenge the security of that valet key for a second. Even with a scoped-down token, aren't we ultimately trusting the agent's internal logic? What if a malicious user uses a prompt injection attack like they trick the agent by hiding instructions in a document to delete all user records? If the agent has the OBO token for the database, doesn't it have the power to execute that destructive command?
That would be a critical vulnerability if the architecture was flawed. But this is where separation of duties comes in. The OBO token enforces least privilege at the platform level, not the prompt level.
Okay, what does that mean in practice?
When the agent exchanges the token, the backend system only grants permission for specific, predefined API actions like read expense report. Even if a prompt injection tricks the agent into requesting a delete command, the outbound API gateway will just reject it.
Because it doesn't have the permission.
Right, the OBO token explicitly lacks the cryptographic permission to write or delete data. The security is enforced by the infrastructure itself, not the AI model's logic.
It provides a hard mathematical boundary that the AI simply cannot cross no matter how confused its prompt gets.
Exactly.
So, looking at the entire board, we have frontier models breaking historical exclusivity. We have automated MLOps and event-driven Node.js support. We have custom CPUs built for orchestration and cryptographic boundaries securing the whole thing. The theory is airtight. But are enterprises actually buying into this infrastructure, or is this just, Silicon Valley hype?
The financial validation we received this week proves this is moving far beyond hype. During the Amazon Q1 FY26 earnings call on April 29th, the leadership team revealed some staggering adoption metrics.
I saw that.
AWS revenue overall grew 28% year over year, hitting $37.6 billion.
Right.
But the specific metric for Amazon Bedrock customer spend showed a 170% increase quarter over quarter.
A 170% increase in a single quarter is a violently steep growth curve. And they noted over 125,000 customers on the platform, including roughly 80% of the Fortune 100.
Yep.
But the metric that really stands out to me is token volume. Bedrock processed more tokens in Q1 2026 than in all prior years combined.
That token volume is the most important data point in the entire earnings call. Tokens are the raw material of generative AI. Processing more tokens in 90 days than in the entire history of the service proves a fundamental shift in behavior.
Because tokens mean actual usage, not just licensing fees.
Exactly. In 2024 and 2025, enterprises were basically in the sandbox. They were building proofs of concept, testing one or two models, and evaluating security. In 2026, those applications are in hard production.
Right.
They are actively serving millions of end users, orchestrating real-world supply chains, and processing live corporate data. It completely validates AWS's strategy of building a governed, multi-model infrastructure. Enterprises didn't want a walled garden. They wanted a secure, agnostic utility, and they are now flooding it with traffic.
It really puts the immense gravity of this week into perspective. We watched the foundational walls come down with OpenAI joining the Bedrock roster via private link. We saw the deployment tools mature with Node.js and rigorous A/B prompt testing.
Yeah.
We saw the physical hardware evolving with Meta and Anthropic consuming tens of millions of Graviton CPUs just to orchestrate the logic. And we saw the security layer lock it all down with cryptographic OBO tokens.
It is genuinely rare to see the foundational models, the developer tools, the silicon infrastructure, and the financial validation all align in a single condensed window of time.
It's a complete paradigm shift, and it leaves me thinking about the people actually sitting at the keyboards right now building this future.
Yeah, and this raises a profound question for you to consider as you architect your own systems. With AI agents now capable of statistically A/B testing
Yeah.
and rewriting their own prompts, with agents writing their own event-driven code via Codex, and securely accessing private corporate databases through OBO tokens without human intervention. At what point does a developer stop being a traditional coder and transition entirely into a manager of a digital autonomous workforce?
That is an incredible thought to end on. You are no longer writing the sequential logic. You are hiring the agent, giving it a cryptographically secure valet key to your data, and simply reviewing its performance metrics. The walled garden is officially gone, and the tools to build whatever you can imagine are sitting right in front of you. Keep exploring, keep questioning the underlying mechanics, and we will catch you next time.